So today we are starting chapter 10, the final chapter. So we are really in the final stretch here, guys. And it has been a tough year, but I'm so proud of all of us for pushing through. So let's get after it. All right, so 10.1 is logarithmic and exponential functions, but it actually starts out with something different than that, okay? So we're starting first with doing some operations with functions, okay? So part one, adding, subtracting, multiplying, and dividing functions. So definition, finding the sum, difference, product, and quotient of functions to generate new functions, right? Because if we like multiply two functions together, we're going to get a new function. And doing these operations with functions is called the algebra of functions. So algebra of functions, let f and g be functions. New functions, f and g, are defined as follows. So these little like first parts here are really just saying like, here's the way we notate it. And then like doing things that we already know how to do. So like, don't freak out because we already know how to do this. It's basically just new notation because we've never seen something like f plus g of x. But really that's just the same thing as f of x plus g of x, which we could totally do. Okay, so it's basically new notation. But let's go over some examples. So read through those algebra functions, see if that makes sense to you. And we're going to do some examples. So example, if f of x, I'll pop that on the other page, I have room. If f of x equals x minus 1 and g of x equals 2x minus 3, find algebra of functions. So first up, we have f plus g of x. And we know that f plus g of x is equal to f of x plus g of x. So if we know that f of x is x minus 1 plus g of x is 2x minus 3, then we can simply add those together, and 2x plus x is equal to 3x. Negative 1 minus 3 is going to be minus 4. So we could say that f plus g of x is equal to 3x minus 4. So now you probably kind of see what I mean about this essentially just being notation. All right, let's do number 2. So number 2 asks us for f minus g of x, which we know is going to be f of x minus g of x. So we know that f of x is x minus 1. And be careful here because we're subtracting the entire quantity g of x. So we're subtracting the entire quantity 2x minus 3, which means we are going to have to distribute that negative. So we're going to distribute our negative and we get x minus 1 minus 2x plus 3. So x minus 2x is going to give us negative x. Minus 1 plus 3 is going to give us plus 2. So now we could say that f minus g of x equals negative x plus 2. All right, let's move into our more harder operations. So next up we have f times, I don't know how to notate times, g of x, which is equal to f of x times g of x. F of x again is x minus 1 times 2x minus 3. That is going to be some foiling action. So x times 2x is going to give me 2x squared, x times negative 3 minus 3x, negative 1 times 2x minus 2x, negative 1 times negative 3 plus 3. So I'm going to get 2x squared minus 5x plus 3 for f times g of x. Creating new functions. All right, and then last but not least, we have f divided by g of x, which we know is going to be equal to f of x divided by g of x. So that is going to be equal to x minus 1 over 2x minus 3. And that's about all we can do right there. But we do want to say that we know 2x minus 3 equals 0. So that's setting our denominator equal to 0. So then we get 2x equals 3. So we divide by 2, x is equal to 3 halves. So we would say that f divided by g of x is equal to x minus 1 over 2x minus 3, and x cannot equal 3 halves because, as we know, if x was equal to 3 halves, our denominator would be equal to 0, which is not allowed. So f divided by g of x is x minus 1 over 2x minus 3. X can't equal 3/2. Which brings us to part 2, which is composite functions. This is a little bit trickier, but you will get the hang of it. And once it clicks, it'll click. So if it doesn't click at first, that's okay. Like, just keep trying, and then at some point it'll be like, oh, I get it. So anyway, another way we construct new functions is function composition. So the composition of functions f and g is, we notate it as like this little open circle. So I kind of read it in my head as fog because it looks like an O to me. It's not the multiplication sign. It's just like a little open circle. So we say like fog of x. And then that is the same thing as f of g of x. So just like we would say that like this is f of 2, now we have this thing f of g of x. So you can see that we're kind of creating a new function by putting one function inside of another. So composite functions are kind of like functionception type deal going on. Okay, so example, we know f of x is equal to x squared and g of x is equal to x plus 3. So I'm going to do some color coding here. So f of x equals x squared. That was a weird word. And g of x is equal to x plus 3. The first thing we are instructed to find is f of g of x, which we know. So first thing we're going to do is take it from this notation to kind of more function notation like this, right? So f of g of x we know is equal to f of g of x. So what that means is we are going to take g of x and plug that in to our function f of x, right? So f of x is x squared, okay? And that's f of x, right? So our x is x squared, except for now we don't want f of x, we want f of g of x. And so what we're going to do is anytime we see an x, so like we know we have an x inside here, but now inside there we have a g of x. So anytime we see an x, we're not going to write an x, we're going to replace it with g of x, okay? So if I look at my f of x function, I see x squared. But instead now of writing an x, wherever I see an x, I'm going to put an x plus 3. So my composite function, f of g of x, is equal to x plus 3 quantity squared. Okay, so again, bear with me as we continue to do these examples. If you're confused, like hang in there. This one's a hard one, but they're gonna get a little bit more natural, a little bit more easy. Okay, so let's do g of f of x. So now we're looking at g of f of x, which we know based on our function composition notation is going to be g of f of x. So again, we know that f of x, whoa, what's going on? No, stop it. Go away. Sorry. We know that f of x, no, I want it in green. We know that f of x is equal to x squared, and we know that g of x equals x plus 3. So now our outside function is g of x, and we're plugging f of x into g. So if I look at my g of x, I know that g of x is equal to x plus 3. But now I want to find g of f of x. So inside there, I'm going to put f of x. And so this means that whenever I see an x in my g function, I'm going to plug in f of x, okay? So g of f of x is going to equal x, except for instead of writing x, now I'm going to write my function f of x, which is x squared plus 3. So I know now that g of f of x is equal to x squared plus 3, okay? I don't actually like that example that I have second, so I'm gonna take a second here. Okay, so now we're gonna do a different example. And we're gonna keep working on this composite function thing because I know it's confusing. So this time we have f of x equals x squared plus 1, and we have g of x equals 3x minus 5. And first off, we're asked to find f of g of x, which we know is equal to f of g of x. And so what we're going to do now is we're going to look at f of x and we're going to plug g of x into f of x, right? So think about like whatever is on the innermost parentheses, that's what you're plugging into the outer function. So my outer function is red, f of x equals x squared plus 1. And you could even think about this as like, okay, I'm taking f, which is x squared plus 1, but instead of writing x, I'm going to leave it open for g of x, and then I'm going to have plus 1. Because I know instead of plugging in x, I'm plugging in now g of x. So now in those open parentheses, I'm going to plug in g of x, which is 3x minus 5. So now I know that f of g of x is equal to 3x minus 5 plus 1, so e equals 3x minus 4. Okay, so f of g of x is going to be 3x minus 4. And now let's do it the other way around. So let's talk about f of g of f of x. So now we're going to talk about g of f of x, which we know is equal to g of f of x. And now our outer function is g. So I'm going to look at my function g, and every time I have a spot for an x, I'm going to leave it open because instead of plugging in x, I'm plugging in f of x. So if I look at g, I have 3 times x, but now I'm plugging in f of x. So 3 times something blank minus 5. And then that blank thing that I know I'm plugging in is f of x. So I'm going to put x squared plus 1. So now I know that g of f of x is equal to 3 times x squared plus 1 minus 5. So that's going to be 3x squared plus 3 minus 5. So that's equal to 3x squared minus 2 for g of f of x. And we can do this with numbers as well, okay? So let's think about if we were asked to find, like back in number 1, where we have f of x equals x squared and g of x equals x plus 3. What if we were asked to find maybe like f of g of 2? So we know that that's going to be f of g of 2. So now what I'm going to do is work my way from the inside out, okay? So first I'm going to find g of 2. So g of 2 is equal to, I'm going to take g of x and plug in 2. So I'm going to get 2 plus 3 equals 5. So I know that g of 2 is 5, so therefore I must be finding f of 5, okay? And I know that f of 5 is going to be equal to 5 squared, which equals 25. So I know that f of g of 2 is 25. It's a little bit easier almost to do this with numbers because you can just start on the inside and work your way out. And then, so yeah. I know that composite functions are a super tricky concept to kind of like get. So if you are still really struggling, please come to tutorial. I can help you work through the math lab problems, help each other out, call a friend, I don't know, whatever you want to do, but I am here to help if you need it. So let me know if you do, because I know composite functions are really hard. But that's all I have for 10.1. Thanks for watching. Have a great day, guys.